Hello. Hello, and welcome to the Android Open Accessories talk. I'm glad you all came. So, welcome to the secret talk. So, as you heard in this morning's keynote, we've been doing a lot of work on Android to make it more open and to enable users and developers to make use of more and different interesting peripherals over USB. So, previously with Android, the Android device supported a certain number of interfaces. You could connect to it as a USB mass storage device. You could connect to it to run the Android debug bridge and so forth. But now we've extended those capabilities with new APIs and new capabilities to attach accessories and to connect to traditional host mode USB device peripherals. So I'm actually going to start this talk. I should introduce myself. My name is Jeff Brown. I'm a member of the Android Framework team. And this is Mike Lockwood, who's also a member of the Android Framework team, and Erik Gilling from the Android Systems team. So I'm going to talk about input devices. So we've got USB, which, USB host mode, which means now we have access to all of the interesting standard USB peripherals that you're used to on a PC. So I've got a USB keyboard here, and I've got a USB mouse. So these are wireless, and hopefully it works. And they're currently plugged in. The dongles are plugged into a standard USB hub. So, all right, pretty much what you would expect. We've got a USB keyboard. We should be able to use it to type. All right, so I've got the AK Notepad application from Android Market. I'm just going to use this as a basic text editor. So, all right, keyboard. I love Android. Sort of. Well, I definitely love Android. So you've got a keyboard. So you can do all the basic things you would expect to do with a keyboard. Control, C, copy, paste, all that stuff. It would help if I actually could see what I was doing. There we are. It's a keyboard. We've also got a mouse. So you got your mouse cursor going around. We support the scroll wheel. And there's new APIs that applications can use to listen to hover events from the mouse and scroll events. This is implemented in all of the standard framework widgets, so you can scroll through lists. You can also scroll around web browser pages. So now that you've got a keyboard and mouse, and you can attach your tablet to an HDMI display, you don't need your laptop anymore. So one other thing I want to talk about, which was mentioned during the keynote, is that we also support game controllers. So we now have new APIs for joysticks. There's a new callback that you can use, you can register on your views, called onGenericMotionEvent. And it exposes all the various joystick axes that exist on a game controller. It also works on flight sticks and other things like that. We've got over 30 different axes plumbed through, including throttle controls. If you've got a car driving rig, that works. 3D positioning mouse is kind of like a joystick. It's just got 6 axes. So you can listen to these in your app as well. So I'm just going to show you very quickly a simple API demo sample. So you already saw this morning the joystick being used to run Cordy. But we have a little sample that's in the Honeycomb 3.1 SDK, which demonstrates sort of all of the data that you can get out of a joystick. So on the left-hand pane, we've got a list of axes. So there's some new APIs that you can use to enumerate the input devices that are present on the system and query the capabilities, query the axes that are available on joysticks, query the buttons that are available, and their ranges. And on the right, I've got a very simple physics-based game. So anyway, that's pretty much it for input devices for now. And I'm going to hand off to Erik Gilling, who's going to tell you more about how USB really works. And what we can do with it.
Thanks, Jeff. All right, so we got two more really exciting accessory things to talk about. But to really appreciate the difference between both of them, I want to lay the groundwork by getting us all on the same page with how USB works from a very high level. On USB, there's a host and a collection of devices. It's important to know the host is always in charge. It has to keep track of when things are plugged in, taken out, what kinds of things are in there. It initiates all data transfer. So the host is always in charge. The way the host keeps track and figures out what kind of devices are plugged in is when they plug in, it reads a list of descriptors. Now, descriptors are a standard format in the USB spec of a bunch of different types. They're hierarchical. So you start with each device has one device descriptor. This describes who made it, what kind of product it is, whether it's a standard class of device or it's a vendor-specific device, and a couple of strings you can display to the user. Device can have more than one configuration, though on most Android devices you only see one. And you can only be in one configuration at one time. Now, configuration has a list of interfaces, and this is where things get interesting. Interfaces generally pair one-to-one with a driver in your operating system. So you can think of a mouse and keyboard combo with like a trackpad on your keyboard. Each one of those will be a separate interface. They'll both be input devices, each one having an instance of the input driver connected. And then an interface is composed of several descriptors. And now here's where your data starts moving. They have 4 different types. They have a direction. They have a max packet size. And yeah, so we got our 4 different types. Control is primarily used to get at those descriptors at enumeration when you put a device in, interrogate the device, set it up. You can have some vendor-specific control requests. Bulk, which are really the workhorses of the USB. You can send just bulk data of fairly large sizes, either in or out, only one direction per endpoint. If you want to do bidirectional, you need 2 endpoints. Then there's interrupt, which are very similar to your bulk endpoints. The only difference here is that they're polled much more often, remembering the host is always in control. Every single data transfer is initiated by the host. So you don't want to send much data over these, but for things like your input devices, keyboards, mice, joysticks, they use the interrupt so that when you press that button to kill your friend in the Quake, it actually happens on time. And then isochronous, which are used for things like audio. They're a real pain to deal with, and forget about them now. So as I said, we have 2 different kinds of accessory APIs coming up. To talk about the first one, the host mode, I'm going to give it over to Mike Lockwood.
I'm here at Google. We've got 2 new APIs for USB and Android 3.1. The first one I'm going to talk about is the host API. And this is for Android devices that have USB host support. Won't do any good on devices that only act as the device. And this can be used for writing apps that can communicate with standard peripherals designed for a PC. Or you could develop new pieces of hardware that specifically for Android and use these APIs with that. So the API has a number of new classes to it. The first 3 correspond directly to some of the descriptors that Erik just talked about. There's a USB device class that has the vendor ID and product ID. You'd first, when something gets plugged in, you'd look at that and say, is this something I'm interested in talking to? And you could do that based on the vendor ID and product ID, or maybe based on the device class, subclass, and protocol, which are usually used to define standard types of things like mice, keyboards, cameras, where you don't really know what care what the manufacturer is, but you care more about the functionality it has. And then from the USB device class, you can get a list of the interfaces, and that also can have a class, subclass, and protocol field that you might be interested in. And then finally, from the interface, you get a list of the endpoints. And the 2 we care about here are the bulk and interrupt endpoint types. Those are the type you'd normally use. Each of these have a specific direction. If you want to talk in both directions, you have to have one endpoint in the out direction, which means PC to device or host to device, and then in is from device to host. And then two more classes, the USB device connection and the USB request classes. The USB device connection is kind of like a file descriptor. When it's something you use that you open the device. This lets you communicate and send data back and forth across the endpoints. Another important thing is the claiming and releasing of interfaces. The USB stack in Linux has this notion of claiming an interface, meaning that you're specifically talking to that interface on the USB device, so you don't have two programs trying to talk to the same hardware at the same time. And then we've got support for both synchronous and asynchronous communication. For asynchronous communication, we've got the USB request class, and that just encapsulates a request to either send or receive data over a particular endpoint. So I'm going to just go quickly through some sample code here. This is some code that basically gets a USB device and decides, can I talk to this? Where are the endpoints I want to talk to? So first, I might look at the vendor ID and product ID and see if those match some values that I'm interested in. Then I look for the first interface on the device. Say I should expect two endpoints, and I say, well, which one's the in direction, which one's the out direction. Then ultimately, I get the EP in and EP out are the two endpoints, the two bulk endpoints I want to talk on. And then once I have that, there's a number of ways to actually communicate with the device, depending on whether you're doing synchronous or asynchronous and what kind of endpoint you're talking on. There's a call USBManager open device, gives you the USB device connection. Once you do that, you want to claim the interface. And then from there, there's a number of different things you can do. There's the control transfers for sending or receiving requests on endpoint 0. Now, Erik mentioned that's typically used for enumeration to figure out what's available on the device. But it also can be used for some extensions, either for a particular vendor or particular class of device. You can send and receive your own commands on there. Then the bulk transfer call, this is a synchronous call. I can pass in the endpoint, a buffer, the buffer size, and a timeout, and either send or receive data synchronously. And the direction, whether you're sending or receiving, is determined by the direction of the endpoint. And then finally, asynchronous requests are good if you want to get higher bandwidth on the bulk endpoints, queue up multiple requests. Instead of waiting for one to finish before starting the next one, you can queue up multiple requests and request, and then wait for them to either be completed, either sending or receiving. And also, if you're interested in listening for interrupts, for something like a keyboard where you press a button and something happens, that's going to happen asynchronously. So you queue up a request and then just wait until something happens, and you get the USB request object gets returned back when that's done. And I think that covers the host APIs, and I'm going to turn it back over to Erik. Talk about accessories now.
Demo?
Oh, the demo.
The demo. You have to do the demo.
This is why they don't let me out very often to talk in public. So. And this is a standard piece of office equipment that many of you probably have in your office yourself. Also, the second reason they don't let me out very often, because I end up doing stuff like this. So this is a USB missile launcher that you can get on a number of fine websites. And it's designed for a PC. There's a Windows app that runs it, but it turns out the protocol that it communicates with is pretty simple. So I've got an Android tablet here with host support. I'm going to plug it in. And I get a dialog saying, do you want to run the MIPS missile launcher application to talk to this device? Click OK, and got, this is an example of my UI design here. So I hooked it up to the accelerometer, and I tilt the tablet, and missile launcher starts turning. Raise the trajectory a little bit here. And then there's a button here called fire. There we go. After this, I want to get a job at the basketball games shooting the T-shirts into the audience. OK, now I actually will turn it back over to Erik since I'm out of missiles.
Thanks, Mike. All right, so Jeff showed you some cool input stuff, and he kind of went over a little bit about how he got to play games in the company time. Mike just showed you how he got to buy toys in the company time. But some of you may have seen a big toy upstairs. I think, not that it's a game or anything, but if it was, I was winning. So this brings us to the Android Open Accessories, which we talked about in the keynote. Now, not every Android device has host mode. In fact, very few Android devices now have host mode. We hope more people will, but what about for the rest of the robots? Well, every Android device that is CTS compatible has to have ADB, which means it has to be a USB device. So let's turn the paradigm on its head. And what if the accessory is the host? Well, that's exactly what we've done with the Open Accessory. It's a simple USB protocol. The accessory is the host and provides power. Yeah. Anyway, so unlike Mike and unlike Jeff, I can't go out and I can't buy one of these. So this is where our ADK comes in. It's a simple board. It's based on the Arduino with some USB circuitry on it. Let's get some light on the subject. Port 3. There we go. I seem to be missing a USB cable. Never fear. All right, so it's got a simple board. It's got the USB host shield integrated on it. And on top of that, we've created our own little Google shield. Now, this has a lot of fun I/O. It's got some buttons. It's got a joystick. We've even bundled a little servo in with it. And much like with a host accessory, you can see that once we pair it with a device, you notice I'm using the Nexus S, which is running our latest version of Gingerbread, which we've pushed out. This does not have host support, so you can't write a host peripheral for this. Now I'm going to plug in the USB connection. And that same basic dialog that you saw with the host mode peripherals opens up, lets us launch an app. Now, this is a pretty simple demo app. My UI design skills are no better than Mike Lockwood's, but I happened to con one of our nice UI designers into making this look pretty for us. So you can see, we've got a bunch of I/O going from the board onto the device. If we go over to the Out tab, you can see we've got a bunch of data going the other way. Green's not particularly boring. Both green is kind of boring. And we also have some relays on the board here, which you can turn on and off. And what's a lot of fun is some servos. Now, I've taken this little servo there, and I've put it inside one of these little Android figurines that we all know and love. So, Android loves you too. Why don't you say hello to everybody, Android? Hi! So, the source code for this, the board designs, the firmware, and the app are all live and released on accessories.android.com now. There's the tablet app. So in order to be one of these peripherals, you don't have to be an ADK. This is just a sample. Microchip has a development kit out. Other people are coming out with development kits. You can do your own custom hardware. As long as you're a host and you can provide the USB spec worth of power, which is 500 milliamps at 5 volts. To get established, it's pretty simple. When you get a hot plug event, you need to interrogate the USB device, and you send out one of these vendor-specific control requests we talked about. This one we came up, we call it get protocol version, and it just returns to you a version number. Now, if it returns to you a version number, your Android device supports the Open Accessory protocol. If it doesn't, It doesn't. Once you do that, you send over data to identify your peripheral. USB has all of this information, all of this procedure for how to identify a USB device to the host. But there's really nothing the other way around. So we had to invent a procedure for doing that. You send over your simple, basic information, who you are, what you are, and where to get software for it. You do that, and then you say, OK, I'm ready to go. Now, this is a little tricky. At this point, your Android device will drop off the USB bus. And it will come back on as a Google-specific device. This has our Google vendor ID and a very specific product ID. Once you see one of these, you know you're in accessory mode. You go dig through those USB descriptors. You find your first bulk in, your first bulk out endpoint. Remember, those are the workhorses. This is where your data is going over. You set your configuration to 1, and now you're ready to go. You're going to get that same dialog you saw, and you're going to be able to have a two-way communication through the app. So now, how do you communicate with the app? I'm going to hand back over to Mike, API Lockwood, and he's going to let you know.
OK, we actually have 2 different versions of the accessory APIs. This is a little bit confusing, but we did this so we could have accessory support both on Android 3.1 and later, and also on Gingerbread. So on Android 3.1, we've got a new package called android.hardware.usb, and this is used for both the host and the accessory APIs. If you know that your app is going to be Honeycomb 3.1 or later, this is the best thing to use. This is on 3.1, which is going out today on Zoom and will be on other devices. But we also wanted to get this working on phones like the Nexus S here. So we've got a compatibility library. It's a different package. The APIs are almost exactly the same. But since we couldn't add any new APIs to Gingerbread, you have to link against this library. And of course, this library is going to exist in future versions of Android as well. So you can use this if you want to support Gingerbread on up to the future. And if you've got a Nexus 1 or Nexus S with the latest update, you've been secretly walking around with this in your pocket for the last week or 2 without realizing it. So there's a couple of steps here. First, you have to make the connection between the hardware and your application. This API just basically is a direct pipe from your app to the hardware. And the way we do this is there's some extra metadata you attach onto your app through the manifest that describes the kind of accessory you want to talk to. And when something gets plugged in, the USBManager will say, well, I've got this manufacturer name, this product name, and this version, and it'll look through and say what apps are available that do that. And then you get the dialog that came up. Also, very similar thing is happening in the host APIs. When I plugged in the missile launcher, we're kind of doing the same thing. Based on what gets plugged in, we say what apps are available to do that. And finally, once the user clicks OK, and you can also say, always use this app so it doesn't keep asking you over and over again, you have an activity that's started with the USB accessory attached intent. And attached to that is information about the accessory that you can communicate with. And then finally, there's another intent that gets sent when you get disconnected. So here's a kind of quick example of what you put in your manifest. You have to have an activity that registers for the USB accessory attached intent. And then there's a metadata thing that basically links to a separate XML file that describes which accessory or accessories you can talk to. And that XML file would look like this here. There's a USB accessory, and you can say manufacturer Acme Corporation, model USB Anvil version 1.0. If you leave out the version, then it would kind of be like a wildcard for any particular version. Same thing with the model. If you want to work with anything from Acme Corporation, you can just omit the other 2. And you can list multiple ones here. If you have an app that can work with a number of different things, it's pretty flexible. And then there's 2 classes. The API is very simple, especially compared to the host APIs. Are a lot more going on the host side than the device side, so this side's pretty simple. There's a USB accessory class that describes all the string fields that get passed from the hardware up to the framework that identify what it is: manufacturer, model, User visible description is what we show in the dialog box when something gets plugged in. The version. There's a URL you can use to point to your website that you can go to for information about the accessory or to download the app. And then there's also a serial number, which is optional. But if your app really needs to keep track of individual specific pieces of hardware, you can do your unique serial number here. And it's the manufacturer, model, and version that are keyed upon to choose the application for the accessory. And then there's a USBManager class, which is used for both the host and the accessory APIs. The accessory-related calls are getting a list of the attached accessories. Right now there can only be one since there's only one USB port on most devices, but maybe that'll change in the future. Open Accessory gives you a parcel file descriptor, which is an Android class that encapsulates a file descriptor that can get passed across process boundaries with Binder. And then from there, you can actually talk to the accessory. Then there's also a couple calls for getting permission to talk to the hardware. For example, if the user doesn't click OK, but then later launches the app and you want to connect to the hardware, you can use these APIs to bring that dialog back up to get permission to talk to the hardware. Which brings up an interesting kind of difference between how this works and a lot of other things work. There's no permission you put in your manifest. Like for the camera, you have to say this app talks to the camera or this app wants to talk to the GPS. For USB, it didn't make as much sense because you don't want to say this app can talk to any possible USB device. So instead, it's kind of dynamically chosen as the user clicks on the dialog. It says this app can talk to this hardware, but you don't have access to every single device. It's kind of a finer grained, more dynamic permission system. And finally, here's the sample of how you talk to the accessory itself. When you get started, you'll get started with the accessory attached intent. You can call get intent from your activity to get the intent. And then there's the helper function here that gets the USB accessory object out of the intent. This is needed for the compatibility API. The 3.1 API, you can just call intent get parsable extra to get the object directly that way. Then you call open accessory to get the parcel file descriptor. Get file descriptor gives you a standard file descriptor. Then you get an input stream and an output stream by opening the file descriptor. And then you can just read and write data using input and output streams. So basically, the accessory looks like a file. And actually, underneath, the file descriptor just gives you a file that directly to the kernel driver that talks to the hardware. So basically, read and write like a regular file, and you're sending and receiving data to your hardware. And then from that level up, it's up to you. There's no protocol defined. It's just sending and receiving bytes. You can invent your own protocol, do whatever you want, and it's up to you. So I'm going to turn it back over to Erik, who's got one more thing to tell us all.
All right. Well, if it felt like we were rushing through this, we sort of were, because I can tell everyone's kind of excited about this, and we want to leave plenty of time for questions. But I think there's one question everyone has on their mind, which is same as CNET. When are we going to make this available? Well, at least for everyone in this room, we've got one ADK for every one of you. Well, applaud everyone else who made it work, too. Now, not only do we have the board that's in here, we're giving you 2 servos and all the cables you need. So I want you guys to go out and make all the next best, greatest Android accessories. And now I'm going to open it up to Q&A.
Stand up?
Yeah. So if you have a question, could you please go to the mic on either side of the aisle, and that way the recording can get it too. When are they getting the boards? Very important question. You'll be getting a card as you exit the door, and then you can take that down to where you got your tablet and your shirt and everything, and you can exchange that for one of these cool white and green tubes. Yes? Oh, can we get the mic on over here?
This morning I remember mention of Bluetooth. What's the API going to be like for that?
Well, right now, we have some fairly rich RF-COM-based Bluetooth support. And so there's no ETA for extending this API into that. However, it is under consideration.
Well, actually, I mean, there's a fairly rich Bluetooth API already. But in terms of human input devices, the same support for USB also works for Bluetooth. So you should be able to use Bluetooth mice and keyboards and joysticks.
And JK's here, who's our Bluetooth guy.
Yeah.
Stand up and look embarrassed. Do you have anything to add? That's like, all right.
So you mentioned the USBManager class had only support for one device at a time, but then earlier you were working with both the keyboard and the mouse and et cetera. So is that just available to you, or did I misunderstand something?
Well, it's kind of confusing because we've got both host support and accessory support. And with host support, like a PC, you can plug in multiple things into a PC really easily. The accessory support is where you're talking over this connection here, which is not host, so it only can connect to one thing at a time. So maybe in the future, if we build a phone with multiple ports in the bottom or something, there'd be a way to do it. But right now, it's just one at a time for the accessory side.
So let's say I wanted to make something like an oscilloscope where there was a fairly high data rate, sampling rate that was needed, a lot of data coming in. Can I do that with the bulk mode, or would I need this nightmarish isochronous mode to do that?
Well, I mean, as far as I understand it, I haven't dealt with isochronous mode before. It's more about guaranteed bandwidth and not as much high bandwidth. So, and everyone I know that have used it has said it's a real pain to deal with. So I would first go down the bulk route and see if that works out for you.
But both are supported?
Oh, the host?
Both of them are supported in the APIs?
Do we support isochronous?
Well, we don't support isochronous
All right,
yet.
well, there's another answer to your question.
Thank you.
Yep.
Hi. During the keynote, we saw something about maybe uploading an app from the
Right.
USB device.
So I kind of glossed over that, and that's my fault. One of those strings that your open accessory, as part of the enumeration handshake, sends to your Android device is a URI. And that can be a web page. It could just be any location. And so what you do is when you're building your device and where you're ready to release that, put a URL in there that describes where to get the software.
Wanted to see if you guys are familiar with the Yo-Yo board and if that's the same spec and everything. They've been pre-ordering those.
That's quite a bit different. That's using ADB, which has been, ADB is the tool that's used for debugging and working with the SDK, and that's available on all Android devices. But it's not enabled by default, and we're not really guaranteeing it's going to exist in its current form forever and ever. So it's not really supported to use ADB for these purposes. But until today, that was the only way you could really do something like that. So that's why IOIO is using that.
See if I can cancel my pre-order then. Thanks.
No. Actually, I can speak a little more. We've been in touch with those folks, and this was inspired in part by that. And there's no reason why your IOIO device, or Yo-Yo, I believe they call it, can't speak this protocol. So please keep it on order. It's a cool device.
Yeah, I mean, depending on what you're trying to do. If it's for hacking and hobbyist stuff, that's fine. I just don't want people to build, expensive consumer things using ADB right now.
Thank you.
So the ADB, or the ADK board is built around the Arduino platform. I assume you're releasing the full firmware for that?
Yeah, absolutely. As I said earlier, the software on the Android side, the software on the Arduino side, the board files, the layouts, the schematics, the BOMs, everything is available on accessories.android.com.
Awesome.
Yep, thank you.
So USB on the go has been supported in tablets under Android for a while. Does this mean that you guys won't lobby to push that into the handset space anytime soon? As in, will we see a handset acting as a real host, USB host, in the next couple of years?
So there's certainly nothing to stop that.
Right. Yeah, the APIs are there now. If a phone supports it, it's really up to the OEMs. I think one of the major limitations is just power. If you're providing half an amp to something, users will be confused and think, oh, this is great, until your battery dies. And that's kind of the main concern, I think.
Yeah, I was wondering about the availability of API 12. You mentioned that's what we'll need to use. Time frame within that.
You mean from an SDK perspective?
Yes.
I believe the SDK is released now, yeah?
Yeah, I think it just went out today.
Okay, thank
Can a device, an Android device that is host enabled, can it behave as an accessory device so it can work with the ADK?
If it has USB on the go, then yes.
Okay.
What's the setup time to get the USB connection established?
It's a USB what?
How long is the setup time to initiate this whole handshake?
The whole handshake? Well, because we do the re-enumeration, it takes a little bit of time, but it only happens once on plug-in.
No, but how many seconds though?
I don't have that number. I'm sorry.
Oh, okay. Because the reason why I bring it up is it seems like a solution to the multi-accessory problem is if you have multiple accessories, just kind of round robin who they are, who's host and who isn't. But that relies on a fast setup time.
Yeah, it sounds very complicated and probably breaks the USB spec.
Well, I mean, as far as complicated goes, it's no worse than token ring networks were years ago. So.
Well.
For any custom Android accessories, will there be any sort of certification process or something that has to be done to get a stamp of approval, or no?
We don't have anything planned now, and I think that's a feature, not a bug.
Cool.
Yeah, typically we have seen that in the non-Android world, it was the libUSB that would give the kind of interfaces that your Android space is using. So what, do you have some kind of a bionic libc now? Bionic.
He's talking about libUSB.
libUSB. Sorry.
Oh, we're not using libUSB.
Well, Mike can tell you all about that.
I didn't hear the question.
Oh, he was asking. On a normal Linux system, you have libUSB to do your USB host stuff. Do we have that, or are we using something different, or do we have a bionic version?
Well, and I guess in the Honeycomb, there's the kernel provides a file system USBFS. There's something similar to libUSB that gives you a C API, and then the framework uses JNI with the Java APIs on top of that. We're not using the same libUSB that's out in the standard Linux distributions, though, mainly just for license. We want an Apache 2 solution for that.
Okay.
Yeah, I just wanted to make sure that I correctly saw that USB Ethernet adapters are going to be supported.
A couple of them happen to work now.
Yeah, I don't.
Is there a way we can get that list?
They're not officially supported.
I know exactly what you're referring to.
Yes.
And it's the other way around. On, say, like the Nexus S today, you can do tethering, and your Nexus S pretends to be a USB Ethernet device to your laptop, is what we had on the slides.
Yeah, but the other way around.
Yeah,
where you're in a demo and you don't want to rely on the wireless connection in order to demo, for example, speech or voice recognition, and you end up getting a.
So the best thing I can say is there's no official support for that right now.
Yeah, right now you can do that if you've got root access. You can run ifconfig and bring up stuff from a root shell.
And if you're doing a demo, I encourage you to do that.
The framework doesn't realize it's there. It might say no internet connection, but really it's working because it's just sort of a low-level hack. But you might be seeing people doing that at places like this where Wi-Fi is not that reliable.
Uh-huh. Okay.
So 2 questions. This may be a silly one, but does this affect the power requirements at all with respect to having to, for example, grab wake locks while in the USB mode?
In which mode? Are you talking about the host or the accessory?
Either, I guess the accessory mode.
On accessory mode, the phone is actually probably charging off of whatever it's plugged into. In the host mode, it's the other way around, where the keyboard or missile launcher is drawing power from your Android device. So it's part of the USB spec. Whoever's the host has to be a battery for the other side of the cable.
But I think also what you're getting at is specifically surrounding keeping the device and the screen awake. We don't take any explicit wake locks on either side of the protocol. So if you have an interactive application that you don't want the screen to go asleep with, you should rely on your standard Android way of doing that.
Okay, there's nothing automatic. That's what I mean.
No, there's no tricks up our sleeves there.
Okay, cool. And the second question is, can you give us examples of some real accessories that are being built by some real companies? What should we expect?
You saw an exercise bike up there.
Okay, other than that?
Yeah, there's telepresence robots. This is a very new initiative for us. What we want to do is we want to get the technology out there, and we want you all to create the next best accessory.
Can you enumerate what devices support host mode now?
I can enumerate one, which is our Motorola Zoom.
I think all the fast follower tablets.
Yeah, I think all the fast followers. I guess the real question is I don't know right now. I would go to accessories.android.com, and there'll at least be contact information there.
I'm back.
Oh, yeah.
For the host example, you showed a keyboard and a mouse, where it's obviously tying into the OS and getting the information to the application. Is there something equivalent for the device side where the Android is the device and the accessory is the peripheral to tie into the OS features?
Currently, the accessory API is directly from the application to the hardware. So that's great for like opening up a whole bunch of new possibilities for developers. But the things that are missing are like audio in and out, or input devices over the accessory mode. Those are things that we're considering for future versions where you can tie it directly into the framework or Android system itself.
You just mentioned audio in and out. On Honeycomb with the isochronous mode, would it be possible to do like class compliant USB audio in with this protocol? Or?
Well, we don't have the asynchronous support in the API at this point, so that isn't really something you can do that easily using isochronous. You could, however, use the two bulk endpoints and send audio data using your own home-brewed protocol. They wouldn't be compatible with standard audio USB devices that are out there now, though.
So at this point, that's still TBD?
Yeah.
Okay. Thanks.
For us traveling, do you foresee us any problem getting a tube with a circuit board through security?
Okay. What time? Do you want me to kill it? 10 minutes?
Don't put it in your shoes.
So 5 more minutes or 10 more minutes? Okay. All right.
Any more questions?
All right. Well, in favor of expediency, and to make sure the next people have enough time to set up.